question whether we are alone in the universe has been on human minds for a very long time. Is it hubris to think we are alone in a universe of trillions of stars? It will make us wonder if we are alone even just in our galaxy, the Milky Way. In this video, we dive into the statistical probability of extraterrestrial life and why 85% of astrobiologists now believe we are not the only ones out there. We'll take a deep dive into the habitable zone of our closest neighbors to see which one might be harboring life. The Drake equation was a formula in 1960s that estimates how many intelligent civilizations might exist in our galaxy. The method using factors like star formation, planetary systems, average number of habitable planets, fraction that might develop life, especially intelligent life, and the chances of life developing. The modern statistics help refine these estimates by analyzing data from exoplanets, cosmic observations, and probability models. Together, they give us a scientific way to imagine life beyond Earth. But first, let's see what is the Goldilocks or habitable zone. It is the region around a star where a planet's surface temperature is just right. Neither too hot nor too cold to support liquid water. It is a critical concept in astrobiology for locating potentially habitable exoplanets, as liquid water is essential for life. Let's dive into our nearest neighbors in the galaxy. First up is Proxima Centauri b, located just 4.2 light-years away. It's about 1.2 times the mass of Earth, making it likely a rocky, terrestrial world. This planet orbits Proxima Centauri, the closest star to our Sun, a small, cool red dwarf. But there's a catch: this star constantly sends out powerful solar flares. Could life survive underground here? Scientists aren't sure yet if the planet has an atmosphere. Because it orbits so closely, completing one orbit every 11.2 days, Proxima Centauri b is blasted by X-ray and ultraviolet radiation hundreds of times stronger than what Earth receives. Any breathable atmosphere could be stripped away. Let's visit Ross 128b, the quiet alternative. About 11 light-years away in the constellation Virgo, this Earth-sized exoplanet orbits a calm red dwarf, making it one of the best candidates for long-term stability. It has a mass around 1.35 to 1.4 times that of Earth, likely with a rocky surface and an iron-rich core slightly larger than ours. Its orbit is only 9.9 Earth days, much closer than Earth's orbit around the Sun, but its dim star keeps temperatures in check. Estimates range from -60°C to 20°C, and with an Earth-like atmosphere, the surface could be a mild 7°C. Ross 128b is probably tidally locked. So one side basks in eternal daylight while the other lies in permanent night. Imagine a sky where neighboring planets appear as large as our moon. That's the kind of view TRAPPIST-1e might offer. TRAPPIST-1e is a part of a 7-planet system, sitting squarely in the Goldilocks zone, neither too hot nor too cold. About 40 light-years away in Aquarius, it's considered one of the most promising places for habitability beyond our solar system. Like Ross 128b, it's likely tidally locked, with one hemisphere bathed in perpetual light and the other in endless darkness. Thanks to the James Webb Space Telescope, scientists now know that TRAPPIST-1e doesn't have a thick hydrogen atmosphere or a dense Venus-like CO2 envelope, keeping the hope alive for a potentially habitable environment. Finally, let's journey to Kepler 452b, often called Earth 2.0, or perhaps our older cousin. This planet is about 60% larger than Earth and orbits a sun remarkably similar to our own. Located 1,400 to 1,800 light-years away in Cygnus, it has spent 6 billion years in the habitable zone, plenty of time for life to evolve, thrive, and maybe even glance back at us. Its orbit takes 385 Earth days, almost identical to our own year, and the distance from its star mirrors the Earth-Sun gap. Kepler, for 52b's surface gravity is nearly twice that of Earth, so moving around would be a challenge. Its star, AG2, type like our Sun, is about 1.5 billion years older, and scientists believe the planet almost certainly has an atmosphere, possibly thicker than Earth's, with clouds and active volcanoes. What stops us from reaching distant worlds? Traveling beyond our solar system is limited by physics, biology, and engineering challenges. 5 major barriers stand in our way. 1. Distance. The universe is immense. Proxima Centauri, our closest star, is 4.2 light-years away. With today's technology, it would take 75,000 years to get there. 2. Space radiation. Outside Earth's protection, astronauts face deadly cosmic rays and solar particles. Shielding works, but it adds weight, and more weight means more fuel. 3. Gravity's effects. Humans evolved under Earth's gravity. In microgravity, muscles weaken, bones thin, and the body suffers long-term damage. 4. Closed, hostile environments. Spacecraft are tiny ecosystems. Air, water, and food must be perfectly recycled for years. Microbes can evolve in dangerous ways, posing new risks to the crew. 5. Propulsion and energy. Traveling fast enough to reach other stars in a lifetime requires enormous energy. Carrying enough fuel to accelerate and stop creates a cycle that makes spacecraft incredibly heavy. These barriers are immense, but they also challenge our ingenuity. Every mission, every discovery, pushes humanity closer to the stars, turning the impossible into the possible. While we haven't found a smoking gun signature of life yet, the shift in scientific consensus is massive. We are moving from asking if there is life, to asking where it is. As our telescopes get sharper and our probes go further, the silence of the universe might be about to get very loud. If you enjoyed this journey through time and into the future, please subscribe to the channel.